Good morning, children. Now come to the section 3 of exercise on lens. The first question is, what is the focal length of a glass slab? What is the focal length of a glass slab? In the previous question number 1G, you have been asked to find out the path of refracted ray from the glass slab, and we have answered that the refracted rays also will pass undeviated. So let us again discuss. This is a glass slab. Rays are incident parallelly and perpendicular to glass slab. Rays are incident parallelly normally to the surface of glass slab. When ray is incident normally, the rays are transmitted without deviation and passes undeviated. The rays are incident normally. Here rays are incident normally, so they pass undeviated. Again, they are incident here normally, pass undeviated. Now come to convex lens. We have discussed that the rays are, if the rays are incident parallelly to axis, after refraction, the rays converge at the focus or diverge at the focus. Now, where these three rays will meet? If it is a lens, these three rays will meet each other at focus. Now these three rays are parallel. So they will meet at infinity. That means they will converge at a focus which is at infinity. In a convex lens, rays are incident parallelly. After refraction, they converge at focus. So if we think it as, here the incident rays are parallel. If we think this as a lens, these rays will meet at, refracted rays will meet at focus. Now the parallel ray, where they will meet each other? Rays are parallel means they will meet at focus. That focus is at infinity. So this is telling that focus is at infinity. These three rays will meet, they are parallel, they will meet each other at infinity. So focus is at infinity. So that is focal length is infinity. Question number 2 is asking for the factors on which focal length of a lens depends upon. In mirrors, we have discussed that focal length is half of the radius of curvature of the mirror. But here in the case of lens, these are different. What are the factors that on which focal length depends upon? One is refractive index of lens material, refractive index of surrounding medium, radius of radius of curvature of the spherical surfaces of the lens and wavelength of the light used. So so these four factors affect the length. For example, if a convex lens has focal length of 25 centimeters in air, the same lens will have different focal length in water, inside water. That is because the surrounding medium has changed. Similarly, as we have discussed, a thicker lens has smaller focal length than a thinner lens because radius of curvatures are different. Radius of curvatures are different. And wavelength of light. As the wavelength changes, refractive index of the material changes. So focal length changes. So these are the four. Now this is a very interesting thing. How it depends upon, again I am repeating, refractive index determine the focal length, refractive index of the surrounding medium, radius of curvature of the spherical surfaces, and wavelength of the light. Suppose in air we have a lens here of focal length 20 centimeters. This is air. This is air. So its focal length is 20 centimeters. Now same lens will be used in water. Here focal length will be, new focal length will be original focal length divided by refractive index of water. We cannot say like that, but it will be definitely less than the original focal length. So when the surrounding medium changes, focal length changes. Now the fourth factor, radius of curvature of the lens. Now, this is a thick lens, this is a thin lens. If this is lens 1, if this is lens 2, we know that focal length of 2 is greater than focal length of 1. A thinner lens has focal length greater than a thicker lens. Why? The spherical surfaces have some radius. So focal length is dependent on the radius of curvature of these spherical surfaces. Now you see, this surface has greater radius of curvature. So greater is the radius of curvature, greater is the focal length. So remember, curvature means what? This is called as curvature. This is curvature of a small spherical surface. And this is curvature of a bigger spherical surface. So it has greater radius of curvature because this is the radius. See? If this is the center, this is its radius. If this is the center, this is the radius. So greater is the radius of curvature, greater is the focal length of the lens. So that is why we say a thinner lens has greater focal length than thicker lens. Now, how wavelength of light affects focal length of a lens. Now, we have a convex lens and white light is incident. Now, white light will split into 7 colors, and in a prism we have seen that red will be deviated least, and violet will be deviated maximum. So red will converge here. So this is the focus for the red. Violet will converge at this point. See, you remember prism? So just like prism here, the white light will be dispersed into 7 colors. Red will meet the axis here, so this is the focus for the red. Violet will meet here because violet is deviated maximum, red is deviated least. So focus for violet is closer to lens, focus for the red is farther from the lens. So focal length for the red is greater than focal length for the violet. That is, focal length is changing with color. So focal length of a lens changes with the wavelength of light used. We have question number 3. We have 2 lenses made of glass and ice. They have same dimension. They are identical. So this is glass, this is ice. So question number 2. What are the factors that affect focal length? Here the radius of curvatures are same, every materials are different. Since material of the lenses are different, they will have different focal length. Density of ice is less than density of glass. So here refractive index of ice is less than refractive index of glass. So glass has higher refractive index. Ice has lesser refractive index. Higher is the refractive index of lens material, higher is the focal length. So focal length of the ice will be less than the focal length of the glass. A convex lens is converging by nature. A concave lens is diverging by nature. Why? Why does a convex lens converge the ray? Why does concave lens converge the ray? You have to answer in one line. I am giving a clue. Go to the prism. It is due to prismatic action of lens. Due to prismatic action. In the prism topic, it has been clearly explained. How a convex lens converges the ray, how a concave lens diverges the lens. Please see the topic prism for detailed answers. Question number 5. Can a convex lens diverge the rays? Can a concave lens converge the rays? Yes. A convex lens can act as a diverging lens. When? when surrounding medium refractive index, surrounding mediums refractive index is greater than that of lens material, greater than that of lens material. That means if surrounding medium is much denser than the lens material, then the lens will act oppositely. That is, surrounding medium is surrounding medium is denser than the lens material. For example, we have our glass lens. This is a glass lens. And here we have air. Refractive index of glass is 1.5, whereas refractive index of air is 1. So here the surrounding medium has lesser refractive index than the material refractive index of the lens material. So here this convex line will act as a converging lens. As a converging lens. Now suppose we will dip it in a solution of carbon bisulfide. This is our glass lens. This is carbon bisulfide. Carbon bisulfide, here refractive index is 2. Carbon bisulfide has refractive index of 2 and glass has refractive index of 1.5. So here surrounding medium has greater refractive index than the refractive index of lens material. So here it will act in opposite way. That means it will be now diverging and its focal length will be negative. Your focal length is positive, your focal length will be negative. That means it is acting as diverging lens. Same thing also for concave lens. A lens has linear magnification 3. The object has area 3 cm square. What will be area of the image? Sir, you have not taught it. Here nothing to learn, just think or we make logical deduction. Now for example, object height is 2 cm and breadth is say 3 cm. So what is area? Area is 6 cm square. So object has area 6 cm square. Now image. Linear magnification is 3. That means image size will be 3 times. So image will have height 2 cm into 3. Magnification is 3. So this is 6 centimeters square meter. What will be its breadth? Breadth is 3 centimeter. Magnification is linear magnification is 3. So breadth is 3 centimeter into 3, that is 9 centimeters. So what is area? So area is 9 into 6, 54 centimeters square. So what are you saying now? Area of the object is 6 centimeters square. Area of the image is 54 centimeters square. Now you are clear? Okay. Now, there is a very interesting thing. Now, what is our linear magnification? Linear magnification is 3. Area image is 54 centimeters square. Object area is 6. So how these two are related? So this is 9 into 6 centimeters square. Yes or no? So this is what? 9 into object area. So now see here, 9 is equals to square of 3 or not. So image area